All right, so here's another two-sided limit, and we're going to use limit laws. This time it's a piecewise function. And so with a piecewise function, if we're approaching 2 from the left, then we're going to use the values where x is less than 2, right? And so we'll use this function. And it's pretty easy to do with our limit laws. We can just plug in 2 here, right? We don't have to plug in, even though we're approaching 2 from the left, we're still approaching 2, right? And so we can just directly evaluate it because that's a continuous function. And so it's just going to be 4 times 2 minus 3. And so that'll be 8 minus 3, which is 5. And so that'll be our answer, okay? So even though this function, even though it's not included, 2 is not included in that part of it, it's still all the numbers that are less than 2, which includes 1.9, 1.99, 1.999, right? So it still gets super, super close to 2, even though it's not included with the or equal to 2 there, okay? So you can still directly evaluate it. And here, let's look at the graph. So this is what that function looks like from the left side as we approach 2, right? And so even though it doesn't exist on this particular line, it still gets super, super close to 2. And then as it gets close to 2, we can see that the output is 1, 2, 3, 4, 5. So there's a graphical kind of validation of what we got, okay? So now we're going to do it from the other side. So now we're going to say, okay, what if we approach 2 from the left? Then we would use this one here, right? Where x is greater than or equal to 2, because those are all the numbers that are on the right. So for those numbers, we use this function. And so same thing, this is a situation where we can directly evaluate. There's no limitation. There's no value that would make this undefined or imaginary. So we can just plug in 2. Okay, so it'll be 2 minus 3 in the parentheses squared. And so that'll be negative 1 squared. 2 minus 3 is negative 1. And then negative 1 squared is positive 1. So that'll be our answer for that one. Okay, and the graphical confirmation here, as we get closer and closer to 2 on the right side, we can see that the output gets closer and closer to 1, right? Okay, so what does that mean about the two-sided limit? Well, the two-sided limit, on one side it's 5, the other side it's 1, so the two-sided limit does not exist, right? And so that's our answer for that one, because they're not the same. They'd have to be the same on both sides for it to exist. All right, so last, let's check out checkpoint 2.18, and checkpoint, or I think it's example 2.23 is similar to this, so you can check that out in the book and kind of see another example. But this we can do a couple different ways using limit laws. Now, I can't do direct evaluation because if I plug in a 1 here, I'm going to get 1 minus 1, which is 0 in the denominator, and 0 squared is still 0, so we can't directly evaluate this, right? But we do know how to do things like 1 over that, right? We know that this we dealt with the other day, where we know that as x approaches 1, since we have an even exponent, it's going to go up on both sides, right? And so it would approach infinity. So we can use that to our advantage. If we know this is true, then what we can do is, instead of writing it like this, we can write it as x plus 2 multiplied by 1 over x minus 1 squared, right? This means the same thing as this, right? And so I can just split it up. And then going back to our limit laws, remember that the limit of a product, put this in brackets here, the limit of a product is equal to the product of its limits. So what I can do is I can say, okay, well, that's the same as the limit as x approaches 1 of x plus 2 multiplied by the limit as x approaches 1 of 1 over x minus 1 squared. Okay, so this one's pretty trivial. We can just plug in 1, right? Directly evaluate that. So 1 plus 2 is 3. So this will come out to be 3 times. And then this one, once again, we know that that goes to positive infinity, right? All right, and we know that because this is an even exponent. We would have an asymptote at positive x equals positive 1, right? And so anyway, so what we end up with is 3 times infinity, 3 times positive infinity. So it's a positive times a positive, and if we multiply 3 by infinity, we're just going to get infinity. So the final result here is positive infinity, okay? All right, just same thing as if you add 1 plus infinity, right? Infinity plus 1 is still infinity. If you multiply a constant by infinity, you get infinity. And you can also multiply a constant times negative infinity, and you get negative infinity as well, right? So anyway, this is our final answer here, and we use some limit laws to kind of break that apart and get it into a place where we could evaluate and then simplify and conceptualize it. All right, so let me know if you have any questions about any of this, and next we'll move on to chapter 2 or to section 2.4 and talk about continuity.